Hello Year 6, my name is Mr O'Callaghan, I'm the Director of Science here at Rastrick High School. We've got a couple of videos to show you and a worksheet for you to work through to experience a bit of science before September. Now, this experiment is experiment 3 in your pack and it is the chromatography experiment. The idea behind chromatography is to analyse different mixtures to find out what's in them, okay? And we're going to actually have a look at some felt tip pens today, okay? Now I would advise that you don't try this at home. It is a science experiment to be done in a science lab like I'm here, okay? So you just wait till September to be able to have a go at this. It is an experiment that you will do at school. You'll do it in Key Stage 3 and again we'll do it again in Key Stage 4 where we'll look at in a little bit more detail because it's part of your GCSE. So let's have a look. So what we need for this experiment is our pens to test. We need some water, which is going to be our solvent, and that's going to dissolve the ink in the pens. We're going to need a pencil, a ruler, some filter paper, a splint and a paper clip. Now, my aim in this experiment is to have a look at what different colours are actually found as a mixture in the different pens, okay? And the way we're going to do this, we're going to use the water to separate them colours out. So, what I'm going to need to do first is I'm going to take my filter paper and I'm going to draw a line in pencil about between 1 and 2 centimetres above, I'm going to go for 1.5, above the bottom of the filter paper. So I'm going to draw a line in pencil, okay? Now the next thing is I need to add my colours. Now I'm going to compare 3 colours. So I'm going to do orange, green and purple, okay? So, on my line, what I need to do is I need to mark 3 spaces and I'm going to label them with my colours. So I'll just put an orange, an O for orange, a G for green and a P for purple, okay? Then I'm going to take my pen and I'm just going to add a dot onto each one. There's my green and there's my purple. Now I've done one earlier with black, blue and red as well. And then I'm just going to draw a quick sketch about halfway from the bottom to my line, just with pencil, because that's going to be where our watermark goes to. So, the next thing is I need to place this into a beaker with some water. So I'm going to take a splint, I'm going to fold it over and I'm just going to secure it with a paper clip. So now I can hold that and just dip it into the water, okay? So that goes into my beaker there. Now what we need to do is we need to add our solvent, and in this case, as we said, our solvent is going to be water. Now I'm going to pour the water up to the line that I've just sketched there, okay? We don't want it to go above this line because it'll wash away the colours and it'll ruin our experiment. So I'm just going to get down to the level and I'm going to add the water up to about that line. There it is, just a little bit underneath, but that's fine. Now, if you've got a time-lapse camera at home, what I'd suggest is that you place it somewhere secure and then you film it and see what's going to happen with these colours, okay? So, I'll put that to one side. It does take about 10 minutes, but I've got 3 finished products, okay? Now, I've got my blue and my red, I've got my black and my purple, and then I've got my green and my orange. Now you can see, if I look and show the camera, the red and the orange don't seem to have any other colours in them. Okay, so we'd say that they're not really a mixture. We'd expect them just to have the red and the orange. But if you look at the green, it starts and it's sort of a yellowy green and goes into blue. So that suggests to us that the green is actually made up of yellow and blue. The blue itself, surprisingly, okay, actually has a very light blue and sort of a pinky magenta colour. So you can see that contains 2 different colours. Now the purple is very similar, but it's got more of the pink. So what that tells us, because they're at the same distance and the colours are at the same height, is that they are actually the same colours. So the blue and the purple contain different amounts of the same colour. Now if you look at the black, you can see the red, which is matching up. You can see some dark blue, which is not in the others. You can see some of the green, which matches up with what's in the green as well, and the yellow and the light blue, so it's got a variety of different colours in there, okay? Now, as you're working through the worksheet, what I want you to think about is labelling the apparatus that we set up. Okay, you've got your beaker, your paper, your spots of ink. And then have a think of these questions. Now remember, the same colours would travel the same distance. So think about how you could work out the distance, what piece of equipment you would need to use to work out the distance. Once you've done that, try and have a go at answering the questions. Think about why some colours maybe have moved further. Okay? Hope you enjoyed that, and there's going to be another experiment for you shortly. Thank you. Hello Year 6, it's Mr O'Callaghan again. I'm here with our second experiment, dancing raisins. Now this is actually a physics experiment investigating forces and forces acting objects that are placed into liquids. Okay? Now if we think about it, if we take an object and we let go of it, okay, then it falls. Now, can you think of what forces might be causing that? Okay, pause the video if you want to have a discussion about it. So when I take my ball bearing and I drop it, gravity is pulling this object down, okay? Now this object has mass, okay, I can feel it, so it has a weight, and the weight is the mass and the gravity pulling it down towards the ground, okay? So the force acting on my object is weight, okay? So if I place it into some water, let's say, then we'd expect still, because it's a steel ball bearing, for it to drop straight through. Now, if I take something else like a raisin, now the raisin, let's say it's, even if it's the same size, you can feel it in your hand, has less weight, okay? But let's see what would happen if we put it into water. So it still sinks. Now it sinks because of the density of the objects. The density of water is actually 1 gram per centimetres cubed. And that means if I took some water and I measured a cube, a centimetre by a centimetre by a centimetre, and it was just made of water, and I placed it on a balance, then you have a mass of 1 gram. So that's our density. Now these two objects both sink, which tells me that they both have a density greater than 1. If one of them had a density of less than 1, let's say it was some polystyrene or some wood, then what would you expect to happen? What would happen is that it would float, it wouldn't sink, okay? So that's for water, but let's try something different. Let's try some lemonade. Now lemonade's mainly water, but it's also got some sugars and flavourings in there. But it's also got, as you can see, some dissolved gas. It's got carbon dioxide dissolved into it. Now when I pour it out, a lot of that carbon dioxide comes out, and you can see all them different bubbles forming. Now there's actually quite a lot of carbon dioxide dissolved into the lemonade. Now, what we'd expect again, let's try the ball bearing. I'm going to place it into the lemonade. Now the ball bearing, as it went through the lemonade, it caused more carbon dioxide to dissolve, to come out of solution, sorry. And that's why you saw that froth coming up. Now if I take a raisin and place it in, just as we expected before, you know, lemonade is pretty much water, so it should have similar density, it should sink. And there it does. But as the raisin sits in the lemonade, more and more bubbles of carbon dioxide form on the surface. Now what do you see happening to the raisin? It suddenly started to float, which meant somehow its density became less than the 1 gram, which means its density was less than that of the lemonade, and it began to rise. Let's see. Okay, give it a second. Now can you think why the raisin just suddenly and randomly seemed to just float and then sink again? Here it goes. It's nearly there. It's just stood up on end, and you might see it whilst I'm talking. But what's actually happening, there we go, what's actually happening to the raisin is that the carbon dioxide, which is dissolved in the lemonade, is forming bubbles around the resin. And think of these bubbles like balloons, okay? Helium balloons. The more bubbles that form, the more upthrust and buoyancy that resin gets. And it gets to a point where them bubbles cause the density of the resin to decrease below the density of the lemonade. Now notice that the steel ball bearing has bubbles around it, but the steel ball bearing is so dense that they can't form enough bubbles to lift it. But the resin is just has a low enough density that enough bubbles of carbon dioxide will cause it to lift. Now I want you to think about what's happening in this video as you work through this worksheet. Think about, what's the force lifting it up? Okay, what's the force that pulls things down? Remember, the density of water is 1 gram per centimetres cubed. If the object floats, then it is less than 1. If the object sinks, it is more than 1. Think about that when you're answering that worksheet. Thank you very much.